Hey everybody, John at IPT. We looked at this in the last video. Maybe we'll call this part two. This is TrailCommand's AB60. Um, as I showed you guys before, if you saw the other video, this torque converter is torched. I mean, this was blue. It was probably glowing red hot in the vehicle. So the root cause of this is usually the valve body. So Kenny's going to open this up and we're going to see what's worn out. You know, there's two torque converter clutch related valves that wear out in these, and I'm speculating they're going to be really hammered, and that's the cause of this problem. So I'll just do an annoying voiceover as Kenny takes this thing apart. Hopefully we don't get him upset because I don't want to get hurt. So we've gone over a lot of this stuff already, the different length bolts, and I could probably link in the description valve body videos if you guys are trying to do this yourself. But that's kind of not really the point of this one. So these are our check ball locations in this model. And they vary from unit to unit, but this is pretty typical. And if you have something that's a little different and you put them in these locations, it'll probably work fine. As you can see, we have some of the bolts out of this already. And these last two pieces are not where you're going to see the worn valves. They're going to be a little bit further ahead in this. All right, so we have these special trays, you know, for valve body disassembly, which are kind of helpful. You could put each line up in its slot. You know, you guys got to remember that valve bodies sometimes have as many parts as the whole rest of the transmission, and oftentimes when there's mistakes in the transmission, it's related to a valve body misassembly or check ball location, missing clip, things like that. Guess in the future I'm going to get that vacuum tester hooked up and we could actually show you this valve body wear in these two valves based on a vacuum test, which should be pretty telling. We have a filter, a little check valve, and a retainer that's always going to fall out on us, except for now when we're trying to get it out. The pressure regulator lineup, and this is definitely a source of wear as well. And maybe you could hold that boost valve up because I'm sure it's going to be worn out in there. Yeah, you can definitely see where it gets shiny like that, like right in that area, because that's worn out. And that's something that pretty much gets changed with the Sonic's billet sleeve anyway. That's your spring. Valve itself, and it's got a little seat for the spring. And in all likelihood, that bore is worn out. So we're going to have to bore that out while we're doing this. So now we just let them drip a little bit. And the thing with valve bodies, they require a lot of cleaning, and it's, you know, we're going to fast forward past most of that stuff. And we're marking the check balls again. Maybe I'll put some an overlay or B-roll, whatever you want to call it, to show that for you guys. But again, that's not really the point of what we're trying to do in this video. This is important in transmission repair, that you don't just replace parts. Like, you got to get in there and you got to find the source of the problem. Otherwise, it's going to happen again. And a lot of people in the transmission industry don't grasp that concept. They'll just see burnt clutches or something like that and say, okay, let me bang some new clutches in it and it should be good. And, you know, maybe sometimes it is, but you got to really find out what happens to fix things effectively. Now we're getting down to where we see these problems. We have wear in there.
Big time.
Okay. It's kind of hard to capture on film, but this little valve, give that to Ken, is going to be like a hot dog in a hallway, so to speak. They wear pretty seriously. But this is really, that valve's kind of secondary. There's another one that's usually even way worse. And I don't know if I'm going to be able to capture it on video, but I'm going to try. Okay, so I made a $800 box order, so Uline sent me this handy light, so I figure we'll try it out for seeing what this valve looks like. This is where you see the usually the bulk of the wear is in this valve. These plugs kind of get stuck in there. There we go. Now there's two valves in here. The first one that's going to come out really isn't a concern, but it's the one that's down in there that's usually the issue. Is it sticky?
A little bit. Dragging a little.
Well, it's not so much the stickiness that caused the problem. It's the wear in the valve itself. I don't know.
I get the spring out.
Let me try and get a better position here. What I'm trying to show is this side-to-side movement. It's kind of tough to see, but
Pull it out a little bit. Yeah, right there.
yeah, but again, take my word for it, this thing's another hot dog in a hallway, so to speak. So this little guy, we're going to bore it oversized and put an oversized valve in here. But this definitely has contributed to this converter clutch wear. So this is what we have so far. And now we're going to wash it up, and I'm going to show you guys how to bore it, which I've done in other videos, but never could do too much valve body boring on AB60s because they all need it. All right, we've shown this before, but it pays to show it again. Some of what's going in here are other parts. So accumulator control, pressure regulator, oversized pressure regulator bore, accumulator pistons with O-rings, TCC regulator. This is all stuff that wears out and we need to do stuff about. And this is the boring process. We're making sure that this is all centered properly. Then we're going to cut this oversize and put an oversized valve. And it's kind of like boring an engine out and putting an oversized piston in there. You know, there's not really any performance advantage. It's just a question of restoring this to factory tolerances. I mean, shit rolls downhill, and if your pressure regulator bore is worn out, you're never going to be able to end up with anything good. And the complaints include soft shifts, hard shifts, harsh reverse. It kind of could be a bunch of different things depending on where it's worn. As you can see, the reamer's turning in there. And once it bottoms out, we'll take it out, clean it. We can install our oversized valve. All right, I misspoke a second ago. This is an accumulator control. This is a TCC control. And this is steel sleeve. And this replaces that aluminum one that we showed you before that was worn out. So this thing's probably never going to be able to wear out again. And now we're going to cut the TCC relay valve, which is usually a very loose in there when it wears out, and it's a huge problem as far as contributing to converter shutter. So there's a few different replacements, and this one is going to be a two-step process. We got to drill the whole valve body larger, and then we got to ream it out, and then we're going to put this valve in that has a sleeve on the outside. It's a steel sleeve rather than riding right in the aluminum casting. So now this is phase two. We're going through it with the reamer. Now obviously we have to clean all these chips out of it, and we're going to install the sleeve and the valve. So just as a little side note, much like the accumulator we showed you in the last video that was in the case, this thing is absolutely destroyed and leveled. So there's a couple of these that are the same part number as what's in your case that live in the valve body. So this is the replacement. This is a Sonex piece. So it's going to have an O-ring on it to give us a good seal. It's also going to have annular grooves, which keep it better lubricated so it doesn't score up like that. And this is also hard-coated anodized as compared to just aluminum. You know, these things are pretty problematic. They're almost all deeply scored like that. So that's got to go. So this is the TCC relay with the spring. It's kind of a tight fit. It's got to get pushed down in there. But we need that tight fit because the outside diameter of that sleeve you want to seal to the valve body that we just reamed out there. That's the inner valve, and the outer sleeve needed a little push there. So that inner valve is the same as your factory valve, but again, now it's going to ride in the steel sleeve rather than just riding in the accumulator, in the valve body bore. And now there's an additional retainer for this aftermarket valve. So you got to put a little grease on top of it so it doesn't fall out when you're reassembling it. Now onto the TCC control. That valve stays stock. And then there's a sleeve with a valve and spring inside of it. And that's going to be the new steel housing. So between this, we've addressed the stuff that causes the common problems of torque converter shutter, as well as code P2757, which is a solenoid code, but what it really means is that the converter clutch is slipping. So your vehicle's computer is seeing a difference between crankshaft RPM and input shaft RPM, right? Because when a clutch is locked up, those two numbers should be the same. If they're not, it kind of sets that 2757 code. And those numbers being the same, that's regardless of the flex lockup that they have, which is a partial lockup. But, once that's only a momentary thing. Okay, so once it goes into full lockup, those numbers are the same. Pressure regulator valve that's oversized. Spring seat. Spring. And the boost valve. Then a retainer. Now, if you see, there's a couple different height settings on here for high, medium, and low pressure. So that kind of gets set based on application. You see, this is all different heights. Okay, so this one is going to push this sleeve down the furthest, that one about halfway, and this one the least. All right, I don't know if I want to bore you guys with putting another one of these valve bodies together. We have different videos, and I'll link them in the description. But this is what we end up getting rid of. This is our boost sleeve, pressure regulator valve, solenoid regulator, this piston that I just showed you, TCC stuff. And we also, and again, I'm not saying that if you have these codes like the 2717 or the 2757 that it's caused by solenoids, because it usually isn't. But when we build these, we do change the SLT and the SLU solenoid, which are both related to those codes, but we don't really do it because of that reason. But they can wear out, just like the valve in the valve body. These things have a valve that walks around in there, and it oscillates at 60 hertz, which is 60 times a second. So if you're like most guys that I see that have these things, they never change the fluid, as per Toyota's crazy recommendation. And that gritty fluid coupled with that valve oscillating so quickly all the time, you know, it really wallows out these valve bores as well as the inside of the solenoids. So it's definitely good practice. At over 100,000 miles, we change those valves, or solenoid valves. Please like, share, subscribe, and hit the notification bell.